Now that we know the definitions of rational and irrational numbers, there are some things that we can do. We need to ask ourselves, how can we approximate and compare irrational numbers? And how can we do that using the number line? So as we go through these problems and examples, please make sure you're taking notes. First example says to compare the following numbers by placing them on the number line. So you see we have four numbers here. Some are rational, some are irrational. But what we're going to use is our number line. So as I write in each of those integers on the bottom, I also put in my perfect squares at the top. These perfect squares are rational numbers because they give me the integers at the bottom. Please make note of those now. All right, so let's begin to compare these numbers. So where would 3.8 be on the number line? I want to know, is it bigger than square root of 17? Is it less than? I'm not sure. So I'm going to place it on the number line between 3 and 4. Because it's 3.8, it's going to be closer to 4. Square root of 17, well, is that larger or smaller than 3.8? Looking at my perfect squares at the top, square root of 16 equals 4. So square root of 17 is just bigger than 4, just to the right. If I wanted to approximate it, maybe it's 4.1, maybe it's 4.2. I'm not sure, but I know that it's bigger than 3.8. Square root of 8. On the number line, I will look at the perfect squares and I will move it to where it should be. Square root of 8 is between square root of 4 and square root of 9, closer to square root of 9. It is between the integers at the bottom, 2 and 3, closer to 3. And then finally, I see 3 pi divided by pi. Now, anytime I have pi divided by pi, I can cross that out. And so that's going to leave me with the integer 3. And I know that 3 goes right here on the number line. So when it says compare the following numbers, I can put them in order easily using my number line as long as I have the integers on the bottom and the perfect squares on top. Let's look at another example. Which symbol describes the relationship between the square root of 106 and 10.5? Is it less than, greater than, or equal to? So again, take notes. I'm going to draw my number line. But this time I'm going to be very strategic. I'm only going to draw the number line between 10 and 11 because I know that 10.5 is between 10 and 11 halfway. And I also know that the square root of 6, square root of 106, is slightly bigger than the square root of 100. In fact, I know that it is closer to the square root of 100 than the square root of 121, and therefore the square root of 106 is less than 10.5. The next example, we have a square has an area of 102 inches squared. So what is the approximate length of one side? What is the approximate perimeter? So first of all, I'm going to draw my square, and I know that the area is 102. The way I find the area is multiplying each side x times x, and that will get me x squared equals 102. So how do I find the length of that side? Do not divide by 2. The inverse of x squared is actually taking the square root. And so the square root of 102 is the length of the side of a square. Well, we just saw in the last example that the square root of 100 is 10. So I can say that the approximate length of one side of this square is 10 because it is close to the square root of 100, which is exactly 10. So what is the perimeter of this square? Well, I just need to add up all sides and I will get 40 because the perimeter of a square is 10 plus 10 plus 10, and that equals 40. So you need to take notes on the examples that I just gave you. And as we learn, we practice, we can improve. If you need to rewatch this video for examples, please do so. Otherwise, go on and practice to prepare for your quiz.